Good evening, welcome to YouTube. Thank you for joining us on this Tuesday evening. Welcome to Space Oddities. If it's your first time here, we hope you'll stick around, and you are indeed very welcome. Well, this evening, we've got a few different things for you this evening. Lou will be carrying on with his look at planetary migration in the early solar system. And also today, believe it or not, today is our 4th anniversary show. That's right, 4 years ago. This week we started Space Oddities here on YouTube, and we're going to do a few things to commemorate it this evening, of which more news later. But in case you're wondering what we looked like 4 years ago, this was on our first ever show on May the 30th, 2022. You'll notice that we weren't in glorious HD then, and viewers, it's thanks to your wonderful donations that we are able to do things like improve our technical capabilities. So thank you for that. And there were quite a few of us in those days, but you know, people come and people go. But you will notice Michael there, and Lou, and Daz, and Roger, and myself, and that's what we looked like 4 years ago. So it's been a fantastic 4 years. We'd like to thank you, obviously, the viewers, for sticking with us over these 4 years, if indeed you have, and we're going to hopefully look forward to the next 4 years. So we've got a few things lined up in connection with that this evening. One lucky viewer will be winning a T-shirt this evening. That's right. We're going to do a bit of a competition later to win a Space Oddities T-shirt. So don't go away. Enter the competition. We'll give you more details of that later, obviously. We'd like to thank those of you who joined us for our live coverage of the Starship Flight 12 last week, which was absolutely spectacular. And while not 100% successful, it was a lot more successful than previous Starship launches. So SpaceX are definitely getting there. And thank you very much for joining us, if indeed you did. And if you didn't, why not? Because we had a lot of fun. So without more ado, I think we'll go straight over to Lou. And Lou is going to carry on with his fascinating tale of what happened in the early solar system. So let's give Lou the floor, as it were.
It wasn't fascinating when you talked about it earlier there. I forget the word you used, but it's something.
Snooze fest. It was snooze fest, Lou. That was it.
No. Right. I'm gonna have to work really hard for this not to be a snooze fest here.
No, you misheard me. It was definitely enthralling I used.
Oh, you said no. You said lose fest.
That was it. That was it.
You need a new hearing aid, Lou. So you need a new hearing aid, Lou.
So this is the third in a sequence of how the solar system formed and how it evolved. And we are sticking with our primary theme that nothing is as it appears. The solar system that you have become comfortable with, that they taught you in grade school, or for me, nursery school, was not always the way it is. And so we're going to talk about how the planets have changed and moved and collided and everything else today. And today we're kind of finishing this off by talking about the outer solar system. So in order to talk about the outer solar system, the really important thing, I think, is to talk about the frost line. And the frost line represents the radial distance from the sun beyond which various volatiles like water and CO2 and others can condense as ices. So for this reason, they're thought to mark regions of enhanced particle growth and thus planet formation. More specifically, there's more in solid material versus gaseous material beyond the frost line to build ice grains from, because it's cold enough that things that would normally be gaseous can condense into solids. Additional freezing out can occur as gas diffuses across the frost line. Solid grains can pile up just inside the frost line in pressure traps, and the grains onto which gases condense, a process called heterogeneous nucleation, become stickier with their ice mantles, also favoring yet more coagulation, more planet building. So determining the snow line then for various species, in other words, water, CO2, methane, ammonia, and so on, is key to probing grain growth and planet formation efficiencies in the outer solar system. So the location of the water snow line is pretty critical to the formation of Jupiter and Saturn because at further colder locations, methane and carbon monoxide freeze enhanced the solid surface density, perhaps contributing to the feeding zones of Uranus and Neptune. The latest solar system models also claim that most comets formed even further out at about 35 AU or so. AU for our audience, most of our audience knows this. AU is astronomical unit, the average distance from the Earth to the Sun. So we'll be talking about the AU as the yardstick that we use in this discussion. The frost line, however, interestingly, did not remain static. It migrated drastically over millions of years, and that was driven by changes in the young sun's energy, the density of the primordial protoplanetary disk, and the emergence of giant planets. Models suggest the frost line varied from about 1 AU, about the distance to the Earth, to perhaps 10 or 17 AU in the first 100,000 years. As the molecular cloud collapsed then to form the proto-sun, intense gravitational energy and viscous heating generated immense heat. This heat energy phase pushed volatile compounds deep into the outer solar nebula. Later, perhaps up to 1 million years or so, as gas accretion into the young sun slowed down, or just the sun slowed in accumulating material, the viscous heating dropped off significantly. The disk began to cool and thin out, allowing ice to condense much closer to the sun. Rapid growth of the proto-Jupiter then altered the structural dynamic of the disk. Once Jupiter reached about 20 Earth masses, más o menos, its gravity carved a gap in the disk and created a pressure trap. This kind of fossilized the frost line around 3 AU, kind of pegged it right there by blocking icy pebbles from drifting any further into the inner solar system. So this kept the inner disk kind of ice depleted even as it continued to cool. And today, the water frost line has stabilized at about 2.7 AU. CO2 frost line, about 10 AU, methane at about 20 AU, and the carbon monoxide frost line at about 30 plus AU. So these are distances beyond which these gases freeze out as ices. So, okay, so there's kind of the fundamental thought that there's this frost line that is going to help determine how these planets form. So let's get into it. Let's get into the outer solar system, and let's begin with Jupiter, the king. Or as Dave and I know, we produced a Science on a Sphere program years ago, Dave, you remember, called Largest?
Yep. Largest, yep.
Dumbest name I have ever heard. Nobody watched it because of that name.
Nope.
That
wasn't our fault, though. That was not our fault, but we can go into that later.
That was the marketing team. Yeah.
That's right.
So Jupiter is the largest and most massive of all the planets, and still it only accounts for about 0.1% of the total mass of the solar system. However, it accounts for 60 to 70% of the angular momentum, so there. It formed 4.6 billion years ago from the solar nebula. It's no big surprise. It's considered the solar system's oldest planet, reaching nearly its current size within just a few million years of the sun's birth. So it had lots of material to form from. The most widely accepted scientific model of its formation is called core accretion. This progressive process happened in a few distinct stages. So Jupiter formed probably only 3.5 AU from the sun, just beyond the frost line, right? And currently, you'll know it's at 5.2 AU. Abundant ice and rocky pebbles collided, clumped together, quickly building a heavy, solid planetary core, which was maybe 10 to maybe 18, somewhere in there, masses of the Earth. Once the solid core grew massive enough, its immense gravity triggered a process called runaway gas accretion. It just rapidly sucked up hydrogen and helium from the surrounding solar nebula, and that's important because it had to do this before the sun's solar winds could blow the gas away into deep space. So it had to accrete all this material rather quickly. As we've already learned, Jupiter's interaction with the solar nebula robbed it of some of its angular momentum. That was just pushing against gas and dust as it's orbiting in the early protoplanetary disk, pushing it closer to the sun as it lost energy, only to be pulled back by the orbital resonance with Saturn to its current location of 5.2 AU. This grand tack, as we've called it, not only shaped the inner planets, but it stole material from the region of the asteroid belt, scattering up to 99% of the original rocky debris into the sun or the outer solar system, or perhaps even out of the solar system. And as such, today's asteroid belt contains only about 0.1% of the mass of our moon. It's really rather depleted. Jupiter's composition is about 90% hydrogen, 10% helium by molecule count. It's enriched in heavy elements, 2 to 4 times solar. And that's kind of a fingerprint of icy planetesimal bombardment at its formation. Interestingly, Jupiter has a positive energy balance. This was first measured, by the way, with the Voyager 1 infrared instrument. That means that it is radiating 70% more energy than it receives from the sun. This is driven by residual heat from gravitational contraction, as well as helium rain, which releases gravitational energy and produces additional heat. Jupiter also has a ring system. I bet you didn't know that, but it does. It's a faint ring system. It's a dark ring system formed mostly of silicate dust that is continuously replenished by micrometeorite impacts on inner moons like Metis and Andrastea. The rings are believed to be rather transient dust bands, not a permanent structure. And because of their faint dark nature, Jupiter's rings are the only ring system that was discovered by spacecraft first, not by ground observations. And once again, Voyager 1 discovered the rings near closest approach in 1979. Many moons. So when I was growing up, Jupiter had 12 moons. That was easy. Today, Jupiter has over 100 known moons. The largest Galilean moons, Io, Europa, Ganymede, Callisto, are believed to have formed alongside Jupiter from the material in the disk of gas that encircled the planet. Irregular moons, however, make up the majority of Jupiter's satellite count. They are typically small, rocky objects like ancient asteroids or comets that were pulled into orbit by Jupiter's immense gravity. Many of the smaller moons travel in opposite or tilted directions and are believed to be shattered fragments of larger once captured moons that collided with one another over time. So even the Jovian system has changed over time. All right, so that's at 5 AU. Let's go a little further out. Now we're at the solar system is really widening out and getting very dispersed. And here we are at 10 AU for Saturn, the Lord of the Rings, if you will. As you might imagine, similar to Jupiter, Saturn formed roughly 4.5 billion years ago through accretion of ice and dust grains in the outer solar system. It primarily grew through core accretion, just like Jupiter, wherein a massive Earth-sized core of rock and ice accumulated before triggering this runaway collapse of hydrogen and helium, runaway accretion from the solar nebula. Again, very similar to Jupiter. Saturn's migration, the grand tack, its migration into and then back out of the inner solar system, is a key feature of this grand tack model. It describes how Jupiter and Saturn formed, migrated inward toward the inner solar system, and then reversed course. Saturn's inward migration was also driven by gravitational interactions with a gaseous protoplanetary disk, just like Jupiter. Migrating even faster than Jupiter, it eventually caught up to Jupiter and became locked in an orbital resonance maybe a 3-to-2 orbital resonance or a 2-to-1 orbital resonance. And this resonance pairing created a gravitational effect that opened a gap in the gas disk, altering the disk's dynamics and causing both planets to reverse their direction or attack, migrating then back outward to their current positions of 5 and 10 AU. Again, as with Jupiter, Saturn's migration contributed to the dearth of material for Mars to form. That's why Mars is so small. And planet formation within the asteroid belt, as well as the late heavy bombardment, which we've already discussed in previous shows. It's important to note that without Saturn's gravitational pull to help reverse the migration, Jupiter would likely have continued spiraling inward all the way to the sun, much like many hot Jupiters that we see in other star systems. This would have likely destroyed the developing terrestrial planets or scattered them out of the solar system altogether. So perhaps we owe our existence to Saturn. Saturn also has a positive heat balance, radiating about 80% more heat than it receives from the sun, also powered by gravitational contraction at the core and partly by helium rain sinking through the metallic hydrogen interior and releasing gravitational energy. Saturn is the least dense of all the planets in the solar system. It's got about 0.69 grams per cubic centimeter. Okay, so water is 1 gram per cubic centimeter. So it's dense. It's less dense than water. And you'll often hear the analogy or the fantasy that if you had a bathtub big enough, Saturn would float in it. I'm not sure that's true, but it sure sounds about right. Its atmosphere is about 96% hydrogen, 3% helium, with ammonia ice clouds creating its pale golden color. Blink. Okay, no discussion of Saturn would be complete without mentioning its beautiful ring system. The rings are predominantly made of water ice, maybe 90% water ice, which is why they're so reflective and bright, and we can see them so easily from Earth. They span about 282,000 kilometers, yet, and here's a question for our panel and for our audience. How thick? So the rings are 282,000 kilometers across. How thick do you think they are?
Let's give our audience a chance to answer that before we chip in. So how thick are the rings of that Saturn, guys? What do you think? Put your answer in the chat. Nobody want to have a go? Okay. Well, I believe that the rings are only about 10 miles thick.
10 to 100 meters.
10 to 100 meters.
They are, either way, they are extremely thin. So it's just surprising that you're not seeing straight through them, but they are extremely thin. So let's see, we've sent a few spacecraft to Saturn. The Cassini mission, its data reveals the rings are geologically young, only maybe 100 to 400 million years old. It's a blink of an eye. They likely formed from the destruction of a moon or comet that strayed too close inside what's called the Roche limit and got pulled apart by Saturn's immense gravity. Finally, so Jupiter has 100 moons. Saturn has, anybody know?
Sorry, I missed that. How
many moons Saturn have? No fear looking it up.
We'll go for 163.
No, it's 200 and something. I was just updating the fact sheet, so
I think it's 193.
210, something like that.
We'll add all those together, get an average, and add 50. There are 270 confirmed moons.
270, right? Okay.
Unbelievable. There were 9 when I was giving my little presentation to my.
Yeah, me too. It was 9 when I was young as well. Wow.
Yeah. Just reading my Time Life 1964 book on the planets. There are 9 moons. Similar to Jupiter, the largest moon, Titan, or largest moons, Titan and Rhea, likely formed with Saturn. But beyond that, its small moons were likely captured. Saturn's rings are also kind of a moon factory. Interactions with the rings consistently spawn tiny, icy moonlets, while some of the ring material clumps in to form small moons like Prometheus. And these help the rings themselves. These are called, kind of keep the rings in order. And these are called shepherding moons. Okay, so enough let's go back. Enough excitement. Let's go out to the boring outer solar system, Uranus, kind of a sideways ice giant. So as we were getting our first close-up looks at the planets with Voyager, after the grandeur of Jupiter and Saturn, Uranus at first glance is not much to look at. Rather boring, in fact, a planetary snooze fest. But if we look under the covers, there is really a lot to like and a lot to marvel at. Uranus likely formed 7 to 15 AU, much closer to the sun than its current position of 20 AU. It formed about 4.5 billion years ago, and it's in this outer region of the solar nebula, where temperatures were cold enough for volatile compounds like water, ammonia, and methane to freeze into solid ice. Through accretion of dust and ice grains, then, its core grew to about 10 to 15 times the mass of the Earth. And then gravity, just as we've seen with Jupiter and Saturn, pulled in the remaining hydrogen and helium from surrounding nebula. Because Uranus formed further out than Jupiter and Saturn, there was less material to form from. As a result, its core grew too slowly to gather massive amounts of hydrogen and helium before the young sun's solar winds blew the remaining gas away, keeping Uranus as an ice giant rather than a massive gas giant like Jupiter. As a result of Jupiter and Saturn's migration, right, this grand tack into and out of the inner solar system, Uranus was thrown into the outer solar system, and again, likely was shaped by massive collisions during this process, probably initiated by the grand tack as well, leaving it with an icy interior and a severely tilted axis from collisions, as well as minimal internal heat. Today, Uranus has a mantle of water, ammonia, and methane ices under extreme pressure surrounding a rocky core. Its atmosphere is hydrogen and helium and maybe 2.3% methane, which absorbs red light and gives Uranus its dull, distinctive blue-green color. Uranus emits almost no detectable internal heat, unique among the four giants, making its atmosphere the coldest in the solar system. A stable compositional layer may be trapping the heat in the interior, suppressing vertical mixing and creating a unique high-pressure photochemistry regime. How exciting is that? Don't answer. Do not answer that question. Now, yes, Uranus rotates on its side. It's like a barrel rolling around the solar system. Its axis is tilted at 98 degrees, almost completely tilted from the ecliptic, nearly on its side. This was almost certainly caused by a giant impact early in the solar system history. This extreme axial tilt drives some pretty bizarre 42-year seasons of continuous daylight, followed by continuous darkness. As with the Jovian planets, Uranus has rings, all the gas giants do, 13 narrow, dark rings of carbon-rich particles, nearly the opposite of Saturn's bright, icy system. Like Neptune's rings, which we'll get to, these dark particles are confined to a few narrow bands with broad, empty gaps between them. The rings are likely a result from ancient moon collisions. Billions of years ago, a catastrophic impact likely shattered several of the planet's early moons. The resulting debris settled into strictly confined zones of maximum stability where tiny shepherd moons, right? Remember, Saturn has shepherding moons, help keep the narrow rings corralled. In other words, kept their shape. The outermost rings are consistently replenished by micrometeorites hitting tiny moons, kicking up fresh dust and ice grains into orbit. Unlike Saturn, unlike Saturn's bright icy rings, the rings of Uranus are incredibly dark. some reflecting only 2% of the sunlight that hits them, more like charcoal dust or dark organic materials. So, that's what you get with Uranus. But then it was on to Neptune. And all of a sudden, we have an exciting looking planet, which happens to be the windiest world in the solar system. Far from the sun, in the coldest regions of the solar system, lies Neptune. Similar in composition to Uranus, mostly hydrogen, some helium, 1.5% methane, but far more energetic. Wind speeds reach 2,100 kilometers per hour, the fastest in the solar system. This was thought very strange at first, since Neptune is so far from the sun that drives wind speeds on Earth. Neptune's winds, however, are driven by intense internal heat, incredibly low friction, and rapid planetary rotation, just 16 hours on average to rotate. I say on average because it's a big ball of gas, and the polar regions rotate in about 12 hours, and the equator rotates in about 18 hours. Neptune, once again, has a positive heat balance, radiating about 2.6 times more heat than it receives from the sun, thus driving its violent atmospheric dynamics and winds. All four gas giants originally formed in a compact resonant chain much closer together, spanning maybe 5 to 15 AU. And then roughly 600 million years after formation, a gravitational instability, you know the word, grand tack, broke the resonance, flinging Uranus and Neptune rather violently outward to their current positions in a short but catastrophic orbital makeup. So their current positions are at 20 and 30 AU, Uranus and Neptune. As Neptune migrated outward to 30 AU, it swept through the primordial Kuiper belt like a giant broom, capturing Pluto, we think, and hundreds of objects into its orbital resonances, and sculpting the structure of the modern Kuiper belt, contributing to the late heavy bombardment. This was about 4 billion years ago. Neptune's rings and moons formed from chaotic sequence of gravitational interactions, primarily driven by the capture of its massive retrograde moon, Triton. This event violently disrupted pre-existing systems, triggering collisions that created the modern inner moons that we see today, and creating and scattering the dark, dusty rings also seen today. Triton is the largest of Neptune's 16 moons. It orbits in a retrograde direction, in other words, backward against the planet's spin, strongly indicating it originated in the Kuiper belt and was captured by Neptune's gravity early in the solar system's history. When Triton was initially captured, its orbit was highly eccentric. This is from computer models. It would have plowed through or completely destroyed perhaps any of Neptune's original system of moons. As Triton's orbit eventually circularized over millions of years, its gravitational influence threw the remaining local moons into disarray. These satellites smashed into each other at high speeds, triggering catastrophic collisional cascades. And the debris from these pulverized moons coalesced to form the current set of inner moons, like Naiad and Thalassa and Despina, and, or is it Despina? I think it's Despina, Galatia and Larissa, and Proteus. They represent this second generation of Neptune's moons. Neptune's rings are relatively young and short-lived, continuously replenished. You've heard this before, by micrometeorite impacts on the inner moons, or by moons occasionally straying too close and being torn apart, being within the Roche limit of Neptune. Because of its retrograde orbit, Triton experiences severe gravitational drag. It is slowly spiraling inward toward Neptune. And it's predicted that in millions, perhaps tens of millions of years, Triton will cross Neptune's Roche limit. The planet's immense gravity will then rip Triton apart, likely creating a spectacular, brilliant new ring system around Neptune that perhaps would dwarf anything we see in the current solar system. That would be something. Now, there's one planet we still have not talked about, and that is Planet 9. Planet 9 is a massive, as yet unconfirmed, hypothetical planet in the outer solar system. Research into its existence is split kind of between gravitational modeling of distant Kuiper Belt objects and their orbits and direct searches using infrared sky surveys. Its existence is based on the clustered orbits of the trans-Neptunian objects. Recent computer simulations suggest that Planet 9, estimated to be maybe 5 to 10 times the mass of the Earth, may be shepherding long-period trans-Neptunian objects, TNOs, into Neptune crossing orbits. The hypothesized planet lies, we think, incredibly far from the sun, with a semi-major axis updated in recent research to something like 290 plus or minus 30 AU, so really far out there, making it exceptionally faint. It currently sits in an area of the sky, if it exists at all, with dense background galactic light, and that kind of complicates visual confirmation. However, astronomers are now pinning their hopes on the Vera C. Rubin Observatory in Chile, with its wide field, deep field, wide angle capabilities. Researchers are hopeful it will either definitively spot Planet 9 or rule it out entirely. And I will end there.
Let me ask the viewers a question. People on social media have been saying, oh, you know, we can visit Planet 9 if it's discovered. Do you know how long it would take a spacecraft using current technology to get to Planet 9? Anybody like to take a guess how long it would take to get to Planet 9?
How far out was it, Lou? Just remind me.
290 AU plus or minus 30.
290 AU. Okay.
290.
Yeah, I know. Plus or minus, I got you. But thank you.
Yeah. So no guesses. Well, with current technology, with current rocket technology, it would take about 40,000 years to get to where Planet 9 is. So
40,000 years?
Yes. However, the robotic missions, the Voyagers, are traveling at about 3 AU per year. Yes. So if you use them as a model, it would take about 100 years, and you'd still never get there alive.
Yeah, exactly. So there we are. So thank you very much, Lou. That was that really interesting.
Anybody still awake out there?
Yeah,
I see it. Okay.
Good. Getting lots of comments, Lou. I think they're paying attention.
Good.
Yeah.
Excellent.
Yeah. So thank you ever so much, Lou. As always, absolutely fantastic. And you know, it's just we look at the solar system now, and we do tend to assume that, you know, it's always been like that since the birth of the solar system. But of course, you've shown us that that wasn't the case. That the early solar system was an incredibly mad, violent place, and took a long time to settle down into the solar system.
And it's still changing. I mean, I'm imagining
absolutely
groups of our audience just cowering in their closets, shivering with fear. Who knows what will happen next? We don't know.
No. Everyone's getting out now to see Triton get destroyed and form these beautiful rings, which you know,
something to look forward to. Thank you, Dave.
Just have to wait a little bit longer, and that's going to happen, right?
That's right. Yeah. What time is it?
Right. Exactly.
Won't the ring system of Saturn have gone by then? So we'll need a new ring system.
That's right.
That's
time
right.
anyway.
That's right. That's right. Conservation of ring systems. I think that's important.
Yeah.
You heard it here first.
Well, anyway, Paul says nice presentations. Thank you for that, Paul. And Mike Beer says brilliant. Thanks, Lou. So at least two were awake, Lou. So that's good.
Thanks, guys.
Hey, Lou. Yeah, Lou. I don't know if you or maybe someone else knows this. I don't know these. So all these systems we found with the giant hot Jupiters, have they also found smaller planets in those systems? You know,
yes.
or terrestrial type planets? Okay. So it doesn't rule out.
No,
although maybe it rules them out in the habitable zone. I don't know.
Yeah.
I just wondered. If that was really a death knell for a habitable planet, or you know, having, or you know,
that's a
or
great.
if Saturn really saved our bacon, or you know, maybe we still would be here. I don't know.
So,
we don't know, I guess, what degree of disruption they caused, but I believe there are multiplanetary systems that have hot Jupiters.
Okay.
Inside the orbit
Just
of
curious.
Mercury.
Yeah.
Thank you very much for your very generous donation so far this evening, everybody. And it's very kind of you. As I always say, all the money that you kindly donate to us goes towards keeping us on the road. So that's good. If you would like to support Space Oddities to enable us to keep bringing you the science, quality science that we think we bring you every week, you can do so in a number of different ways. The first thing is you can buy us a coffee by scanning the QR code or clicking the link in the chat that's just appeared, and that will take you to the Buy Me a Coffee page where you can keep our caffeine levels stocked up. We also, of course, have the Space Oddities t-shirts, and they are at £20, including UK postage and packing. And we have the Space Oddities hoodies as well, which are £40, or from £40, including postage and packing. And again, if you're outside the UK, please add total £10 to the total value of your order. And summer's here, so you definitely need those t-shirts. So why not buy a Space Oddities one? And speaking of the Space Oddities t-shirts, we are going to do a quiz for you this evening to celebrate our 4th anniversary. We're going to do a quiz, and the winner of the quiz will win one of the aforementioned Space Oddities t-shirts. And in case you don't know what they look like, the Space Oddities t-shirts look like remarkably similar to this. So this is our Space Oddities t-shirt. And wouldn't you like to win one of these for the summer? Of course you would. And all you have to do is to enter our competition. So let me tell you how the competition is going to work. Daz is going to give you a quiz where all of the answers, and there are 10 questions in all of the answers involve in some way the number 4, as it's our 4th anniversary. So all you have to do is to write down your answers and put them in an email, and I'll give you the exact details now. So we have to go through this for legal reasons on YouTube. If we're doing a giveaway, we have to display the rules and the details. So write down the answers to the quiz, pop them in an email, send them to giveaway@spaceoddities.space. That's giveaway@spaceoddities.space to arrive no later than the end of next Sunday, which is the 31st of May. The winner will receive a Space Oddities t-shirt, and we'll announce the winner and give you the answers to the quiz on next Tuesday's live stream. There's no cash alternative, no alternative prizes. It's a t-shirt or nothing, I'm afraid. If we do have a tie, we will select a winner at random. And if you'd like a full copy of these rules, please email info@spaceoddities.space. So that's the quiz. Write down the answers, put them in an email to giveaway@spaceoddities.space, and you could win yourself a fantastic Space Oddities t-shirt. Once we have a winner, we will contact the winner to get their details off them for the prize. So that's it. So I'm going to hand you over to Daz now. And again, can I ask the team not to blurt the answers out, please?
That's easy, because we're not going to know the answers.
I don't know. They're all 4, though, I thought. That was the thing.
Well, I hope people were listening, because Lou gave the answers to 2 of them.
Yeah, I know. Okay, take it away, Daz.
Right. There we go. Right, can everyone see that?
Yeah.
Right. So, as we said, now this was supposed to be just a bit of a fun quiz. So it's very, very easy. We'll probably get everyone's answers will be 100%. So it'll come down to a draw at the end of it. But have a bit of fun and enter it. And as Andy said, basically, as the title here, just think 4. That doesn't mean the answer's 4 to every question. But just have a bit of fun.
Glad you threw that in there, Daz. Thanks.
Yeah. Well, I know some
I thought it
people
was.
need explaining, don't they, Lou? And poor Dave as well. Poor Dave. Oh, bless him. Yeah, okay then. So what we'll do is we'll give you the questions. As Andy said, we'll give you the questions this week, and then next week we will give you the answers, and hopefully be able to tell you who the winner is. So here we go. And as I said, oh, anyway, I've just forgotten to do something for myself so that I can. Where is it?
So while Daz is sorting that out, viewers, grab yourself a pen and paper, and eyes down for a full house, as they say.
Yeah. Right. The first one's for a line. Okay then. So I just had to get my presenter view up. So okay then. So let's go for the first question. And as I said, they are simple. Try not to overthink these, or else you'll end up, confusing yourself. So here we go. Can you name the 4 largest moons of Jupiter, and what is another collective name for them? So again, name the 4 largest moons of Jupiter, and what is another collective name for these moons? That's question number 1. Question number 2 is simply Mars. That's all you're getting, Mars.
Thanks a lot.
Oh, don't want to make it easy for you. And question 3. Can you name the 4 fundamental forces which govern all interactions in the universe? So this is what keeps the universe together and doing what it does, doing its universe things. So can you name the 4 fundamental forces which govern all interactions in the universe?
Oh shoot! I thought 6, 7 was one of them, but that's not a number.
No, it's Earth, Wind, Fire, and Water, right? Those are the.
Oh.
Well, Dave, you were not supposed to shout them out.
Oh, that's right. I'm giving it away.
Right, you'll go get disciplined.
Bad boy.
Okay then. Right. So, question 4: what phenomenon do we experience on Earth which is influenced by the Earth's axial tilt and orbit around the Sun? So again, what phenomenon do we experience on Earth which is influenced by the Earth's axial tilt and orbit around the Sun? Hope everyone's got that.
Does dizziness have
No.
4 letters? Let me think. D-I. No, it doesn't. Okay.
Right. Number 5. A series of 4 consecutive total lunar eclipses with no partial lunar eclipses in between is known as a what? A series of 4 consecutive total lunar eclipses with no partial lunar eclipses in between is known as what? Question 6. Please name the 4 main classifications of types of galaxies. So again, please name the 4 main classifications of types of galaxies. As I said, a lot of these are so simple. Right. Question 7. Mercury, Venus, Earth, and Mars. That's all you're getting. Mercury, Venus, Earth, and Mars. Eight. What is Chon? C-H-O-N. Again, what is Chon? C-H-O-N. What 4 directions of the celestial sphere are often used in navigating and understanding astronomical observations? Again, What four directions of the celestial sphere are often used in navigating and understanding astronomical observations? And finally, 10. What are the four stages of our sun's evolution? What are the four stages of our sun's evolution? And that's it.
Thank you very much, Daz.
Hope
Absolutely.
everyone got that.
Yeah. Okay. What we might do before the end of the show is just to quickly go back over the questions again.
Yeah,
Quick.
no problem at all.
So write your answers down, put them in an email, address them to giveaway, one word obviously, at spaceoddities.space. And may the best person win. And whoever does win, we will send a T-shirt to. And if we have a tie, we will do a random selection of the winner. So we do trust you, of course, not to immediately get onto Wikipedia or Google or ChatGPT to find the answers. We do trust you to have some degree of honesty, but we know you do because you are wonderful viewers and you wouldn't cheat. We know that. So yeah, so no cheating. As simple as that. Okay, so we move on. And I think if I remember rightly, yes, we're going to go over to Roger now, because it's the start of that wonderful season of the year known as Noctilucent Cloud season. So Roger's going to tell us a little bit about that. So let's get this up for you, Roger.
Okay, so just in case you're unfamiliar with or have not even seen it with your own eyes, here's the background about noctilucent clouds. Okay, so what are noctilucent clouds? Right, they're basically noctilucent clouds is Latin for glowing after dark, and the reason that they might appear to be glowing after dark is because of the type of material that these clouds are made from and the height they are above our atmosphere. More about that in a moment. So they're roughly 50 miles above the sea level, which is much higher than normal clouds can ever get. And because of that altitude, the air pressure is 100,000th of what it is at sea level. And it's in the mesosphere. So it's above the troposphere, the stratosphere, and the ozone layer. So it's got its own little area there, which enables it to do what it's going to do. And we'll go into that in a moment. So what we need to do, as it says at the bottom of the slide, is that the temperatures can reach as low as minus 143 degrees centigrade. So even below the point of freezing water. Okay. So here it gives you an idea of the different spheres around the Earth. So we start with the troposphere, where we've got the normal height for aircraft and stuff. Stratosphere, where we've got some balloons that can go up to do weather mapping and stuff. The mesosphere, which is where the meteorites usually try to burn up in the atmosphere. And then we start to get into the more exotic stuff further out, and then into the exosphere, which is roughly where the satellites and the geostationary satellites are orbiting above the Earth there. Okay. So what do we need? There is some water vapor out there, but it's fewer than 10 parts per million. It's also partly made of dust particles from micrometeorites, ash, and other pollutants. And all that with the cold weather will enable it to freeze quite an amount to start to reflect the light back. So we've got in the summer, which is where we usually get it, is the rising polar air added adiabatic cooling and ice nucleation. So with all these different things happening, it will give you these periods around this time through the summer months to seeing these lovely phenomenon. So so we've basically gone through what the different actual atmospheres are for that. So it was only originally early sightings roughly in the 1870s by astronomer Thomas Romney Robinson, but this is an unconfirmed. 1885 was the first confirmed documentation of it, and it was only 2 years after the Krakatoa eruption. So whether some of that dust that got forced up into the atmosphere was possibly the first documentation of that event to make it happen. And they're normally seeing above the 55 degrees latitude north, and maybe a little bit further down, but we also have that down in the southern hemisphere as well. There seems to be observations that methane is triggering more of these phenomenon as well, with the water vapor being produced from that to create more of these noctilucent clouds. So it's a possibility of that we're starting to see more of it coming into the more recent times. So we've also got volcanic eruptions and rocket launches, which may also contribute to some of the particulates at this point of the atmosphere, which might also contribute to noctilucent clouds as well. So basically, in the northern hemisphere, it's roughly 60 to 80 degrees north of the equator, maybe down to 45 degrees, but mostly the noctilucent clouds are much more commonly visible between 60 and 80 degrees north, and rarer down below. But in the southern atmospheres, it's just between 45 and 60 degrees. So a little bit lower down in the southern hemisphere than what we usually get in the northern hemisphere. Okay, so they start roughly about now through to about mid-August, but in the southern hemisphere, it's between late November to early February. So obviously the similar seasons to we get here to what they get over there during that time. So when the sun is between 6 and 16 degrees below the horizon, it's usually about an hour and a half before sunrise and an hour and a half after sunset. You might be able to start to see the effect, which is when the angle is just right to reflect the sunlight off those clouds to get you to see them. And they're usually obviously mostly familiar in Scandinavia, Scotland, Canada, and New Zealand. Okay. And did we have that picture there? The picture that is on this slide is one that I took myself, and was the first time that I took it, actually physically saw it, and it was a very good image to see as a first time spotter of noctilucent clouds, and that was about 6 years ago.
Lovely image, Roger.
Yeah, that's beautiful.
Yeah.
Hang on, there's more to come.
Oh,
so we've got them. They've been classified like some galaxies, which I won't go into shapes to give away the answers. We've got a veil or banding. We've got them in waves, whirls, and amorphous. So there are some sort of similarities in types of noctilucent cloud that we'll be able to document and categorize depending on how they're formed and whereabouts they are in the latitudes of the atmosphere as well. So they can produce some quite phenomenal results, as is this picture here, which I took with also Comet Neowise. And this was during the sunrise, and this was back in 2020.
Beautiful image.
Ooh.
So I got two
Wow.
objects for the for the price of one.
Jeez.
You should send that into
That's like
astronomy picture of the day.
Astronomy picture of the
Yeah.
day. That's exactly what I was going to say.
Absolutely.
That's definitely
Yeah.
That's
Be
gorgeous.
famous.
Apart from the fact that it's 6 years a bit too late, I don't think that would qualify,
Don't
would
put
it?
a date on it.
I think the comet might give it away.
It might give it away. Yep.
Discovered a new comet, Roger. That's amazing.
Yeah. Or you could send it into an even more well-known publication, which is the Space Oddities Gallery.
There you go.
Oh,
Yeah.
yes.
Well,
Yeah.
that's
Pinnacle.
pretty high standards, though, right?
That's true.
So there we have the basics of what noctilucent clouds are and how they're formed.
Thank you, Roger. And if you
Bravo.
take any photographs of noctilucent clouds during the noctilucent cloud season, send them to us at Space Oddities. Attach them to an email, one per email, please, and address them to gallery@spaceoddities.space. And we will show them on Tuesday. And of course, you get your own gallery on the Space Oddities website, which, as you probably know by now, is https://spaceoddities.space. And we wish you good hunting for noctilucent clouds. Keep your eyes out because you never know. So there we are. All right. Well, we're going to move on now, because next we move over to Dave with another episode of his fascinating back of the week in space exploration. And Dave, over to you.
Okay, give me one moment here, and let's see. I got to do that and share the screen. Okay.
Okay.
And here we go. Let's see.
Oh, wrong one. Oh, what's
No,
that
I'll
now?
get it. I've got it. Hang on a second. All right.
Okay.
Are you seeing it?
That's it. We're seeing it. Yeah.
Yes. Okay. All right. So this week, 24th through the 30th. Well, there's a bunch of stuff this week, so I'm going to run through some of it, but some of it is really fascinating, so I may be spending a little time on it. Okay. So May 24th, 1962 was the fourth Mercury launch. Alan Shepard and Gus Grissom did suborbital flights, and then John Glenn was the first to orbit the Earth. Scott Carpenter became the second American to orbit the Earth on May 24th, 1962. It was a perfectly uneventful flight until somehow there was a 3-second delay in beginning the retro rocket refiring to re-enter the atmosphere. And there was also a yaw error. The spacecraft wasn't quite oriented correctly. And so he ended up splashing down about 250 miles beyond the intended recovery area, which gives you an idea how fast these things are going. It's a small 3-second difference. Ended up taking about 3 hours to reach him. So he got out of his capsule and sat on top of the capsule, I guess, while it floated around in the ocean, and waited for 3 hours for them to come and pick him up. But other than that, it was a very successful flight, and another quite an achievement for the Mercury program. Okay, so here's a big day, May 25th, 1961. 65 years ago yesterday, if you're keeping track, and President Kennedy got in front of Congress and said, basically, I believe this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. And back there in the back left is Lyndon Johnson, who of course was pivotal in actually making this happen by building up NASA to unprecedented size and abilities and capabilities at that time. Okay, May 25th, 2008. So 18 years ago yesterday, the Phoenix lander touched down. You probably remember this. Yeah, it was so despite all the evidence that there was water on Mars from orbit in photography, this was really the first thing that it dug down. It dug down to the water ice because it was near the northern pole, and it dug down, made some trenches, dug down to the water ice, and saw actual ice and frost, and so it was the first absolute evidence that there was ice on Mars, and not that it was in doubt, but it's something, and quite a just another amazing picture from the surface of Mars. I can't get enough of these. I think they're just it's so cool seeing the surface of another planet. But now this picture down, and I'm going to show you a larger view of this in just a second. This picture down in the lower right is absolutely amazing, because this was taken, and let me show you a larger version of it. This was taken by the Mars Reconnaissance Orbiter. And the little square box there is actually the Phoenix lander descending to the surface. And it's a little blow up there in the very bottom left corner. That's spectacular, right? The Mars Reconnaissance Orbiter was in the right position in its orbit and actually managed to take a picture of this thing descending. It's amazing. Okay, anyway, there's not much more you can say about that. I just think that's spectacular. Okay, this is cool. This was 95 years ago, May 27th, the very first human ascent to the stratosphere. So Auguste Piccard Paul C. Nipfer, Paul Nipfer, ascended to almost 16 kilometers, so over 10 miles. In other words, reached the stratosphere, and basically were the first people to claim they saw the curvature of the Earth. Now, of course, they may just be part of the conspiracy that the Earth's not really curved. But they said they saw. No. Supposedly, I mean, they would have been the first people at a height, and they did see the curvature of the Earth, which is also really cool. But now, what's really kind of cool about this whole thing, and I don't know if you remember, if you were watching a couple weeks ago, I talked about the first positive measurement of protons made from a balloon. This was a balloon at the University of Minnesota, a program that was run by, that was started and run by an aeronaut named Jean Piccard. And so just amazing as it is, Jean Piccard was Auguste Piccard's twin brother.
Oh, wow.
Yes. And he ended up also going up into the stratosphere in a balloon with his wife, Jeanette, only a few years later after his brother Auguste had gone up, and making her the first woman to ever ascend to the stratosphere in a balloon or in anything. Okay, to go on, Auguste Piccard's son was the first. Okay, wait a minute. So let me back up a second. Auguste Piccard had a son named Jacques Piccard, first person to descend to the Marianas Trench. So, first person in the stratosphere's son was the first person to the very bottom of the ocean floor. Also, his student, Jean Piccard's student, was Robert Gilruth, and that name may be familiar to you because he became the director of the Manned Space Center, Space Flight Center during the Apollo era. And it was actually Jean Piccard who invented the pyrotechnic releases that ended up being used for the Apollo missions. They were using those things for balloons, and it ended up being the things that they released for the Apollo missions.
Oh, wow.
Yeah. So there's all these funny connections between these guys. And okay, and now so here's there's another thing. There's Jacques Piccard also was part of was the captain or the basically the person who started and invented the idea of the Gulf Stream drift mission, which you may not have heard of, but they developed a submersible called the Ben Franklin, which Jacques Piccard captained, and it just basically floated along the Gulf Stream and made measurements the whole way. And my father actually worked on that mission because it was built by Grumman Aircraft Company.
Oh,
Finally, we're not done yet. The name Picard may sound familiar to you, and Jean-Luc Picard, the captain of the Enterprise in Star Trek Next Generation, was actually named for the Picards, the Picard brothers. One less C. He only had one C in his name, but actually there is. I guess they even hint in the program that he is a distant relative, a great grandson of Jean Picard or Jean or Auguste Picard, one of the two, but is actually related to them.
wow.
So, yeah. Anyway, these guys they flew from Augsburg, Germany, and they ended up landing in a glacier in Austria in the Tyrolean Alps. At first, I guess there were some reports that they thought that they had died after making this giant ascent into the stratosphere. But of course, they were fine, and they were recovered, none the worse for wear. And anyway, just lots of interesting stuff. I thought it was a fascinating thing. But the very first people to go up into the stratosphere, up in this sealed sealed balloon, they had some problems. They had a leak, which they had to plug up. And they also had problems because it was supposed to rotate. It had a motor to rotate it, so it would keep a light side towards the sun if it was getting too hot, and a dark side if it was getting too cold. They didn't know exactly what they were going to experience up there, but the motor broke, and it ended up had temperatures up to 104 Fahrenheit inside the capsule. But again, they were fine, and so quite a mission. Okay, so let's see. I already did that. All right. May 28th, 1959, first successful launch of monkeys into space. Abel, a rhesus monkey, and Baker, a squirrel monkey. Abel in his little sort of space harness, I guess, on the left there, and Baker posing with this little spacecraft model on the right. It became quite a thing. They both survived the mission. 6 monkeys before this had died in various missions, but so these were the first 2 to actually make it and survive for any amount of time. I guess one of the monkeys actually survived for a very short time after it landed, but only for minutes or something. So it wasn't. Not very successful, but they went over 300 miles high, and recovered by the USS Kiowa boat, and yeah, apparently they were both in good spirits and very good, and they became almost a little bit of celebrities. There they are on the cover of Life magazine in June 1959. But it was not just kind of neat to send monkeys in space, but it was okay. Here, look, we have real good solid evidence that that primates that and hopefully presumably humans could go into space and survive the conditions, because really no one had any idea what would happen in zero gravity. There were ideas that you might not be able to breathe, that the food in your stomach might start floating up into your esophagus and choke you. They just really didn't know what zero gravity was, and there really wasn't a great way to test it for any longer than in an aircraft for a few a couple of minutes or something. Okay, 585 BC. So now we're really going back. First purported successful prediction of a solar eclipse by Thales of Miletus. Anyway, and supposedly there's still some argument about this, whether he would have possibly been able to predict an eclipse based on the knowledge they had, because of course they didn't have knowledge of eclipses where they were occurring. I mean, eclipses were occurring all over the world, but in Greece they might know about a few eclipses here and there, but they probably wouldn't have known about an eclipse occurring in South America or Australia or something like that. So they didn't have a lot of information. So it's still a question about whether he possibly could have known this was happening. But apparently he he was just out drinking, and so told the bar he bet that there was going to be this eclipse, and everything was going to happen the next day, and it did. So he gets credit for no, not true. he did make this. He's actually been called the father of Western philosophy, and he was one of the first people to really invent the idea, well, mathematics and just deduction, logical deduction and that sort of thing. He was one of the earliest sort of proponents of that. And so it's claimed anyway. And then there's a lot of witnesses from that time had written and claimed that he had indeed predicted this eclipse on May 28th. So. Launch of Mars 3 orbiter. So this is the first soft lander on the Martian surface. I think it was last week or the week before was the Mars 2, which became the first thing to actually hit Mars, but did not ever transmit upon landing. Mars 3 actually transmitted only for about 110 seconds and sent back an image which was completely gray, but that was possibly due to the fact that there was an immense dust storm going on at the time. So hard to say, but anyway, the very first successful soft lander on Mars. Okay, this is pretty cool, and everyone kind of knows the story, right? This was May 29th, 1919. Was the solar eclipse that actually basically proved Einstein's ideas about how gravity affected light. This confirmed it, and what they did was obviously they took pictures of stars, and if you can see on the right there, the right picture of the eclipse in the very upper right, there's you can see four little lines. That's an image that was taken by this Sir Arthur Eddington. May not have been Sir Arthur at the time, but Arthur Eddington in any case. And that's an image that he took and then marked the positions of the stars so that they could compare it to images of the same spot once the sun was out of the way. And indeed, it showed that they were displaced by about 1.5 arc seconds, which was what Einstein predicted they would be. And so it was basically the very, very first solid observational evidence of the theory of general relativity, which is pretty amazing. It actually turns out that they tried to do this in Brazil in 1912, and it was rained out. They went to Crimea as part of Russia to observe the eclipse of 21 August 1914. However, a month before that, World War I had started, and so the they basically got kicked out. And some of the astronomers who were German were actually imprisoned for a while. 1918 they tried again, and they got clouded out and had some problems with faulty equipment and couldn't get one. So this was the first one that actually did. And it was fortunately because Einstein had to make a correction based on his theory of general relativity in 1915. And it turns out that if they'd made the measurement before that, the number that he had was based on Newtonian physics would have been slightly wrong. And so this number matched exactly to what he predicted. So it was probably better for his reputation anyway that they missed the first few. All right,
hey, Dave.
Surveyor 1. I know it's funny. What's that?
Am I right that the stars in question were the Pleiades star cluster?
Hyades.
The Hyades.
Thanks for bringing it up. I did meant to say that. Yes, the Hyades group. They knew it was going to be close to the moon, so it was a group of stars, which of course is much preferable to having one or two single stars, and because then they could, of course, obviously, being slightly different distances, the paths of light from the sun, they could compare also the stars to each other and say, okay, this one's 1.47 arc seconds and this one's 1.43 arc seconds. They could actually get even a better statistical model. Okay, Surveyor 1, first U.S. soft lander on the moon. Another amazing achievement, for the U.S. space program, and pictures from the surface of the moon. Pretty spectacular. These were they were done with little tiny, lots and lots of tiny pictures. Thousands of tiny pictures were sent back, and they actually physically they printed them and pasted them onto a sort of a hemispherical shell. And then they took a picture of that, and that's the picture you're seeing here. And that's why you can see obviously you can see each individual frame, all the little boxes. It almost looks like it's underwater or something. But those are the little frames, and they actually were basically pasted up to this thing, which would then correct for the aberration that was caused by the camera lens and all that. And so try to correct for that, they put it onto this hemispherical shell. Inside of a hemispherical shell, and then they took a picture of it, and that was their first images of the moon. And launch of Mariner 9, May 30th, 1971. First spacecraft to orbit another planet, and basically same as these Mars, same time as the Mars 2 and 3. There was a huge dust storm on the surface when it first got there, so they were worried at first that either Mars was very featureless or that something was wrong with the camera. And when the dust storms started to subside and they started to see some detail in the dust storms, they realized what was going on. And a few weeks later, the dust storm subsided, and they managed to get these amazing pictures of Mars, which rewrote their view of Mars, because the flyby seemed to show it looked more like the moon. And all of a sudden, they were finding all this detail that showed all this activity. Anyway, and that is it. Okay, so thanks so much. Tried to get through that fast enough, but there was a lot. All right. Thank you.
Thank you very much, Dave. That's another lot of very, very interesting information. So thank you for doing that. Really much appreciated. Okay, viewers, what we're going to do now is we are going to go over again to Uncle Roger for the weekly look at the night sky and the viewers gallery. So let's put that up on the screen for you, Roger, and there you go.
Okay, so we're coming through the end of May and starting into June. Okay. I don't know whether many people are aware, but as of yesterday, we have now lost astronomical darkness in the UK. So, oh, right. Okay. Thanks for that. So it's going to be a bit limiting now for a little while until we get the other side of June. So astronomical darkness will start to appear latter part of July and into August. So hooray for that. Right. Okay. So we're working our way through to a full moon at the weekend. So it's going to be just as we finish May, we have a second full moon.
Oh,
or a blue moon.
Yes.
So there, right. So when it does get eventually dark here, we still can see in a bit of daylight still from after the sunset. We've got Jupiter and Venus above the western or northwestern skies. So still a few planets to see, but nothing much else apart from that planetary wise. But we have had a good long run of seeing Jupiter and at quite a good altitude as well, which is beneficiary for those that like to observe it without all that atmospheric disturbance that we usually get when they're further down in the sky. And as you can see, we've now got the summer triangle coming up through with Vega, Deneb, and Altair coming through in the latter stages of the night time. So all's well with that. And we've also got the Milky Way coming up through, making our skies look rather nicely decorated.
Indeed.
And of course, and obviously with Scorpius coming up through in the southern skies, we've got a Fucus there, and we've got lots and lots of clusters and nebulas and all these wonderful things coming up through the Milky Way system as well. So lots of interesting photo opportunities for those deep sky photographers when it will get dark again. So we've still got a little while to go before we get to that, but the constellations will be in a better position as time goes on, obviously. Okay, so before sunrise, we've obviously got Saturn, Mars, and Uranus. Uranus getting quite close to the Sun from our perspective, and then following on after sunset, we've got Mercury, which can be spotted, but be very careful on its position. And then obviously we've got Venus and Jupiter. So we've got six planets on show, 3 either side of the Sun. So one would probably call it a planetary parade, but obviously with the faintness of the planets against the brightening skies, it will become a much of a challenge. So don't really try it too much. So here we are, a picture that I took a few days ago, just after sunset, where you've got the Sun, Venus at magnitude 3.9 and Jupiter at -1.9. So quite a nice way to see it, even with just binoculars, just to get a nice view of some bright objects before it gets totally dark. Okay, where are we? Right, and then we've got obviously we've got another moon, full moon coming up through at the end of the month, so could be a good opportunity to get a juxtaposition of a moon rising above some point that would make a good image. And we've got some transits as of this evening. We've got Europa doing a shadow transit across. So if anyone does like to see these phenomena, it's all well and good, and quite an interesting thing to spot. And if you're quite lucky like this evening, you might be able to get an opportunity before Jupiter gets too low down, as this will be about 10:30 tonight. So still a good chance to see something there. And then we've got Venus near M35 in Gemini at one end, and Jupiter at the other end near Castor and Pollux. So that's another good chance to get something interesting. Okay, so we have got quite a bit of interest on the Sun at the moment. We do have some groups of sunspots coming around again, and some prominence action as well. And as opposed to last week, where there was hardly any corona holes, we do have a couple in the northern part and the southern part, just for a change. So that's good. Normal service has sort of been resumed. And onwards with our gallery. We do have a few entries here from our regulars, and we've got one here from Ian, who took a picture of the moon through his window.
Oh, very artistic.
Yes, very artistic.
Atmospheric.
Yeah, very
yes.
Yeah.
Well done, Ian. Thank you for that.
Thanks,
It's
Ian.
been a little while since you took a picture and posted it to us, but well done. And we've got a few images from Michael Murphy of some solar activities. So here's his first image that he took, which was on the 20th of May. He has numbered the active region groups there, so it's quite interesting to see how they progress across the surface. So this is on the 20th, and we've got one on the 23rd, and as you can see, we've got a change of some spots there. It's nice to see how they track across and how they sort of evolve as the rotation happens. And sometimes you usually get some breaking up or some actually joining in. As we can see on here on the 26th, we've got quite a few more groups here, which can make for quite a good view. I would think that would be quite good for a visual observer to see that sort of quantity on the surface there as well.
So I'm
Oh,
trying to guess where the solar equator is. There's this butterfly effect, right, where the sunspots tend to migrate toward the equator up to solar max.
Yeah. I think we've got these images rotated. They're sort of rotated about 40 degrees counterclockwise. So that's not a true representation of the actual latitudes of these groups. It's just the way it's been taken. But we get as they're all in the same orientation, we do get a good idea of how they do form and rotate around the surface there.
Yeah, I think active region 4451 is actually should be on the 9 o'clock position, which would then give you the equator. They'll be going from left to right.
Yeah, so they need to be rotated about 45 degrees clockwise.
Yeah, nearest.
Right.
Yeah.
Okay.
Yeah.
Okay. So they are, they are pretty much bunched around the equator then, yeah.
And here's one from our absent member on the panel, one from Michael, with the Moon, Jupiter, with Castor and Pollux and Venus, which was on the 21st of May, then on his iPhone.
Oh, beautiful.
Oh, nice.
And
nice.
there is, if you can just about see some Earth shine as well there.
Yeah.
With Jupiter down below with the Venus.
Yeah, you can just see the three.
Just down over the gaps between the houses and about level with the top part of the cloud, where you can see Venus. And then Castor and Pollux in between the Moon and Venus.
Yeah.
Nice.
Oh yeah. Yep. Okay.
Okay. All right.
Cool.
Thank you, Michael. We've got one from Jerry. So we've got some galaxies here to have a look at. And some of those various types that were in the quiz.
Whoa.
Oh, nice.
Oh, look at that.
Jeez. Wow. It's like one of those deep sky images from Hubble or something.
Yeah. So if you start to study it even more, you will notice more and more much fainter galaxies in the background, apart from the ones that we can obviously see much bigger and brighter on this image. Well done for that. Okay. And then finally, a couple of lunar images by me taken last night. As it was fairly clear. So
lovely.
Yeah.
Lovely,
so if you have a look on the left image, about halfway down on the terminator, you can see the straight wall. It's just in complete shadow there, so it's just about hitting the light rays right on the edge there, just before daybreak appears further over onto the western side there.
Are you referring about 2/3 down?
Yeah, about 2/3 of the way down.
Yeah, you can see that straight line, straight dark line. Yes, very good.
Right on the edge of morning there.
Beautiful one.
Okay, so that's what we have for this week's Night Sky Guide and Gallery.
Thank you very much, Roger. Thank you very much indeed. Well, we've been thinking about the number 4 a lot this evening because we are 4 years old this week. And what we thought we'd do, which we'd like you to participate in views if you would like to, is just make some predictions for the next 4 years. And today we're just going to let's concentrate just on solar system exploration. So what do we think is going to happen in solar system exploration during the next 4 years? And what would we like to see happening, which may or may not be the same thing. So let's go over to Lou first of all. Lou, next 4 years, what's going to happen in solar system exploration?
Well, some of it depends on NASA's budget, but I'm really hoping. You know, we ignored Venus for so long, and Dave, you remember Gordon Chin at Goddard? Yeah, he put in something like 5 proposals for a mission. We call it Vesper. They're all turned down. But finally, there were 2 NASA missions that got selected. There was Da Vinci and
Veritas.
thank
Right?
you. Thank you,
Yep.
Veritas. One was a JPL mission, one was a Goddard mission, I think.
Yep.
And my understanding is that their funding has been cut. I'm not sure if it's been cut completely or put on the back burner, but I'm really hoping that they launch. And then the only other thing that I would say is that for the last decadal survey, a Uranus orbiter was at the top of the list or very close to it. And so I'm hoping we get to see at least the launch of a Jupiter orbiter, a Uranus orbiter.
Uranus orbiter. Yeah.
I was reading that that particular project may be delayed because of a shortage of plutonium for the RTG. And that may put the launch date back. In any event, we're not going to see it arrive at Uranus till about 2045, maybe 2050 if it's delayed because of a plutonium shortage. So, we've got a lot. I mean, it's a great idea. We'd all love to see that spacecraft go to Uranus and get some high definition images, because after all, we only have the Voyager close-up images of Uranus and its moons. I'm far more interested in seeing images of the moons than I am of Uranus itself, for fairly obvious reasons. But there would be so much great science to come out of that mission, but we may not see it arrive at Uranus until 2050.
Yeah.
So
just one correction, Andy. You use plutonium to get to Pluto. It's uranium to get to Uranus.
Oh boy,
I think you'll have to take that up with the engineers, because I think they would disagree with you.
Neptunium is really hard to come by.
That will make
quantum
sense.
zone.
Oh, I thought geraniums were in the garden.
Okay, can we just go through some what our viewers have been saying? Barry says land a Starship on the moon already. Yeah. Ian says we'll get to Europa with probes. Well, we've already got 2 on the way, so arriving in 2030 and 2031. So that's definitely going to happen unless something goes wrong on the way. Derek says landings on the moon and more rovers on Mars. Mike says a mission to Venus would be so cool. Well, no, it wouldn't. It'd be extremely hot. And Derek says, can we make something that would survive a landing on Venus for more than half an hour? So that would be good. I'm sure with modern technology we could definitely improve on the Venera probes. So,
which lasted an hour.
Which
anyway,
lasted an hour, yeah.
So we could do that. I don't know how long the Da Vinci probe. I mean, the Da Vinci probe is mainly designed for atmospheric, study on the way down. I don't know how long that's designed to last on the surface.
Does it have an orbiter as well?
Da Vinci, I think, is just a probe.
Just a probe.
Yeah.
So Bob says faster rockets. Barry says, I don't think there will be any manned landings on Venus.
There's a safe bet.
I can think of a few people.
There was a BBC 2-parter series back in the 90s. It was very good, and it was basically a spacecraft with people visiting every planet in the solar system.
I remember.
It did a great job of showing what the surface of Venus was actually like. But what would be the point, basically? No, manned landings on Venus, I think we've got higher priorities than that.
Maybe a balloon mission to Venus to float.
Yes.
Well, yes, that has been suggested many times.
Right?
Yeah.
Exactly.
And the Soviet Union did
atmosphere.
that. Yeah, the Soviet Union did successfully drop off some balloons that inflated themselves and floated in the cloud layer, basically up at that altitude. And it lasted for quite a few hours because, of course, the conditions aren't that harsh up there.
And Mike says, what's the latest on phosphine in the atmosphere? The latest is, Mike, that it's still unconfirmed. There have been more tentative discoveries, but nothing is confirmed. And the latest belief about this is that if the phosphine is there, it's at a much lower altitude than was thought. So, so that might affect things.
I think it's sitting on top of another molecular line, which makes it a little hard to, ferret.
To identify, to separate, right?
Yeah. Fred says Starship will lower launch prices, so new players and nations and universities will enter planetary exploration.
Yep, that could be.
Maybe. I mean, Starship is meant to have a projected launch cost of below $2 million, as against the $4 billion for SLS.
Pocket change.
So, yeah, I mean, that's already pretty low. How much lower it can go, I don't know. But that is still amazingly cheap for a rocket launch. So we will see. We will see. So any more suggestions, viewers? Any predictions? Anything you'd like to see? Then put them in the comments. Daz, what about you?
Well, 4 years is such a short time in astronomical terms for any missions. So really, we should be looking at. I mean, most missions, any sort of like probes or anything like that, they're usually talking the average now for some of the outer solar system, 12 years. So over the next 4 years, I mean, we've got so much coming up in the next 4 years, not just solar system, but also beyond. Because we got the Vera Rubin to come online, we got the Nancy Grace Roman, we've got the SKA all to come online, and we're just going to be inundated with data. I would like to think in 4 years' time we got a better handle on all this dark stuff. I would like to think we have, but I think the more we're going to learn and try and find this stuff and debate about what it actually is, we're going to end up with more questions than the answers. It's as simple as that. But it would be nice if we could get a handle on this, and then we can know exactly what the universe is actually doing as regards expansion and things like that. It's just, I mean, what we've got to look forward to is just going to be absolutely astonishing. So in the next 4, I mean even the Europa Clipper and all that lot, they're not getting there until the 30s, which is sort of like on the cusp of the 4-year window. So that's what I would like to be getting into. As regards a balloon in the Venus atmosphere, yeah, maybe it could round up those penguins and find out what they're actually doing. Again, also, then we've got to look inward as well, as regards the sun. We've got to really develop systems for space weather, because the more and more stuff we put up in space, the more and more we're going to have. There's going to be a problem at some time, a big problem. So yeah, we've got to look both inward and we've also got to look both outward. So as regards predictions, I don't know where we'll be. I really don't. It's going to be an amazing time. And the discoveries are going to come thick and fast, but also so are the more questions. I can see it happening. And I'd like to, well, it would be nice if we could just inside that 4 years, is there any life or microbial life on any of these ice moons?
Sample return. There it is. It's sitting there waiting for us.
Ian says, best comment so far, more Space Oddities. Definitely. Thank you.
I didn't want to say that. I'm glad.
I thought that was already, you didn't have to say it. It's just in the case that.
Roger, what about you? Any predictions?
I think it's more worries and concerns about all these satellite constellations being launched, really. I mean, I did some pictures last night through the night to try and do a time lapse, and on almost every frame through the night, I was getting 2, 3, maybe up to 5 or 6 pictures of a satellite trail
Oh my God.
Wow.
Wow.
through the whole night. I mean, it was almost like there was a SpaceX train of satellites going across at some point, because they were sort of going side by side, a lot of them. It's scary, really.
It is.
I mean, the thing is,
don't know.
like you say,
These,
Roger, you're
yeah.
sorry.
It's
No,
just that it completely ruins any
Mm.
astrophotography, really.
Exactly.
So
I mean,
heaven knows what it's going to be like for Vera Rubin and all those others that
yeah,
are going
because
to
I
be.
was just going to
having-
say, for you, they're thin streaks, but for these big telescopes, they're like tree trunks.
Yeah, yeah.
Mm.
They're like tree trunks, and they can completely ruin an observation period. So yeah,
Mm.
sorry to interrupt, Roger.
That's all right.
Yeah. Dave.
Yeah, when you first, first heard this, I thought, boy, I feel like in the United States, to try to predict what's going to be the next 4 days is hard enough right now with the, the climate. So yeah, and what Lou said is really, so much hinges on what happens with the NASA budget. There's a lot of competing forces, and so far, they've managed to keep the NASA budget, but even the threats to the NASA budget, and I saw this happen in real time at Goddard Space Flight Center. Even the threats have caused considerable damage and permanent damage. Even, I mean, for example, we lost our library at Goddard. So the NASA infrastructure is being damaged, even by the threat of the budget going down, and then it ends up, after Congress gets through with it, everything, the budget gets more or less restored. But the other part of that too is a lot of the budget now is going to Artemis. So I think we're losing a lot of the robotic opportunities. I would hope that within a few years that will start coming up, and although we won't be able to do something, as Daz was saying, right, we can't get anywhere, or develop a mission that fast, that at least there will be missions that are planned, that are starting to get, some more exciting missions to go to places, and any place would be good. I hope they'll keep Da Vinci. Da Vinci still exists. Okay, the mission still exists, and I think Veritas also, but yeah, they're severely curtailed until they get more money back to occur.
I don't know whether you saw it last week, but Jared Isaacman sent out a notice to all NASA staff outlining his plans for reorganizing the centers and what NASA was going to do. I didn't, because I don't work for NASA, contrary to popular opinion, and a lot of it was a bit over my head in terms of the organizational chart and who's reporting to who and all this. Obviously, it didn't mean much to me, but the general thrust, he did again keep mentioning again and again the commitment to science and discovery, which I thought was great. As long as he keeps thinking like that and doesn't bow to external pressure, then it sounds good. But I think
that's good. Now the other thing along with that is what I would hope what I hope to see in the next 4 years is a lot more plans by Japan, by India, by the European Space Agency, maybe the Arab Emirates. A lot of these other countries and groups that are starting to really, no pun intended, take off. I mean, with all their the space exploration. I think it's great. I mean, imagine having all those extra resources from all these other countries to learn about the space.
Well, certainly the UAE mission to Mars has inspired a lot of Arab nations to work together to build their own space program. So yeah, he's hoping.
Hey guys, I'm reading Isaacman's letter.
Right.
And he's talking about the centers and the facilities, and he says we will better resource centers to increase specialization in support of the mission directorate, the outcomes we need to achieve. And then down below, he lists each center. And for Goddard, he lists that it is, in fact, the Earth and Space Science Center of Excellence. So I think, just a very terse reading here, it sounds like he's in favor of funding Goddard for their SED, their Science Exploration Directorate, the Space and Earth Science Research. I hope that's true.
Yeah, I hope.
So basically, you're talking about as a centre of excellence without a library.
Without a library, yeah.
I know.
You're just going to Google it anyhow. I mean, come on. Actually, I want to know where those books are.
Yeah, exactly. I was thinking that.
God.
Yeah. Well, I'll have them if nobody wants them.
I was going to say, Dave, have you got a cellar?
Yeah.
They're,
He was digging holes in the garden.
Yeah, he was talking about digging holes.
We know.
You know where they are. They're under the roses.
hiding the books.
They're under the roses.
Yeah. Bob says, Lisa's go, fingers crossed.
Mm-hmm.
Yeah. We've got the launch of Lisa currently scheduled. It's a bit further out than 4 years, but it is scheduled for 2034. But we're really looking forward to that. The Einstein telescope, Europe's gravity interferometer, that is just about to have its final location selected. They've reached the end of the consultative process, so they're just about ready to make the decision of where it's going to go, and then construction will start almost immediately afterwards. So that is expected to be up and running by about 2030, 2031, which will make it the most sensitive gravitational wave detector on the planet. I would like to predict, actually talking about that within the next 4 years, there are going to be some major discoveries made with gravitational waves, with regard to, especially with regard to black holes, but also perhaps the primordial universe as well. I just feel it in my water that we're going to see some major discoveries in gravitational wave astronomy over the next 4 years. As regards the rest, well, I think Artemis will be delayed. I don't think they're going to get to the moon in 2028, maybe 2029, if all goes well, because there's still such a lot to do, and I don't think they're going to make the 2028 goal. But I'd like to be proved wrong, obviously. And in terms of exploring the solar system, I think we will. I think there are still some surprises left in data, like Cassini data, and maybe an older data than that. I think we'll make some very interesting discoveries about the solar system from existing data, because there's enough data there to last decades. So I think we'll see some. Yeah.
Yeah, because they're already going through.
Coming up. Actually, speaking of that, I was watching the TV series For All Mankind on Friday, and they've got to the episode where humans set foot on Titan for the first time, and I was looking forward so much to that, and they just got it hopelessly wrong, because they descended through white clouds onto a grey landscape with grey overcast skies. I thought, that's not the colour of Titan. Titan does not look like that. But then I thought about it, and I thought, well, it kind of looks similar to Mars. So because a lot of the action takes place on the Mars base, I think they probably had to distinguish the
make it different
landscape from the Martian landscape, because they're roughly the same color, sort of.
Yeah, it was the same it was the same with Lou's presentation with Uranus and Neptune.
I don't know.
They had the colors were different, but of course, when you actually put them up properly, the colors are almost very similar.
Yeah, they are.
Okay, I have a thought that it's possible that this is real. So I scuba dive, and one of the things they teach you is that if you're taking pictures, or if not, if you're just looking at pictures, that the deeper you go, the less color there is.
Right.
Okay. So that's because there's less light and the way your eyes operate and so on. So, so what does Titan get? Well, at 10 AU, that's 1% of what the Earth gets. And then about 10% of that makes it to the surface. So that's 0.1%. So it might be that on Titan, things look a bit gray on the surface because there's just not much sunlight.
That could be.
Yeah, that's a good thought.
It was a good episode, though, I have to say, apart from the
I have to start watching it.
Yeah.
Yeah, I haven't seen it either, but
well, I've got it from the beginning, so I can share it with you. So it's been really good. I've really enjoyed it. Meanwhile, on Mars, the Space Marines had landed to put down a rebellion. So
that happens.
Space Marines.
Yeah. Yeah. All right then. Well, listen, I think we'll leave it there. We'll go to our last section, which quite predictably is Constellation of the Week. And this week's Constellation of the Week will be delivered to us in his usual accomplished style by Roger. So
Hey,
for you, and I suppose it's a large one.
that's what she said.
Oh boy.
Right. Yeah, it's one of those larger ones that Mike likes to avoid, unfortunately. Yeah. So there we go. So we're into the constellation of Perseus this week. Just for just a matter of change, we've done quite a lot of the surrounding constellations. So Perseus will go into the character as the son of Zeus, and was the slayer of Medusa.
Indeed.
That Gorgon, and saved the Princess Andromeda from certain fate worse than death. So honored him obviously with celestial skies. So here we go. So it's one of the 48 original constellations listed by Ptolemy in the 2nd century. It's the 24th largest in the sky, and covers a mere 615 square degrees.
Oh wow!
So it's not too bad. A lot of people will probably be familiar with it, obviously because of some of the objects that are contained herewith. But some of the stars here we have is Murphak Alpha Persei, which is a yellow-white supergiant. We've also got Algol, the infamous demon star, Beta Persei, which is a eclipse in binary. And then we do have some other stars in there, which we will go into with some other objects. Obviously, we've got Algol. That's an interesting picture there. It's obviously got one of the
has a hole in it.
Going it. Yeah. Must be the eclipse, the eclipse in binary of it. So obviously a bit dimmer than the main star there, obviously. So it can be visible to the naked eye, the dimming of it. So obviously worth a look if you like a bit of variable star observations. But obviously a lot of people will know Perseus from the double cluster NGC 869 and 884, which are visible with the naked eye, but better with pair binoculars. And then we've got Messier 34 for a nice bright open cluster, which can be quite nice. And if you've got a decent sized telescope, you might be able to pick out the little dumbbell nebula as well. Which can be it's not very big, but it does look quite nice, as from this image that I have got here on show. I have got something similar, but not quite as clear as that, unfortunately. But there we go. And also we've got the California Nebula, obviously named after its shape, that it represents the state of California. So name it after what you see, basically. And can look quite interesting in normal visible light, or in narrowband as well, where some people like to give it some interesting colors. And then we've also got a Perseid meteor shower, which will be about mid-August with up to 100 meteors per hour. So that will be quite a good popular site for people to sit out and watch for without too much of a wait, spotting something else to look at. And then we've got the Perseus cluster, Abel 462. So we've got a massive galaxy cluster, which is roughly 250 million light years away. And there are 6 confirmed exoplanets as well within the Perseus star systems. And there we go on that. So obviously best to see roughly at its peak, roughly about December time. And obviously because it can be quite interesting to see some of the objects there, it will be a good time with the early nights there as well. Visible right down to 35 degrees southern in the southern hemisphere. So most people will be able to see it one way or the other. And here we are, we have got most of the details here. And that will give you the brief rundown of the constellation of Perseus.
Thank you very much, Roger. The good news is that the Perseus meteor shower this year occurs, the peak night of 11th, 12th of August occurs around the time of the new moon. So we're not going to have any disruption from the moon this year. It's not many years we don't get any interference from the moon. So it looks like it's going to be a wonderful year for Perseus, given clear skies, of course. So get out there, take your cameras, get some shots of the Perseus in August and send them to us, basically. Good luck.
And also the solar eclipse in August.
Oh, absolutely. Solar eclipse here in Spain, which I don't think I'll be getting to after everything for one reason or another. But I'm going to definitely go to next year's if I miss this year. So we got the 12th of August is a total eclipse. And in Europe, Spain is going to be the best place to view it from, going right from the northwest coast of Galicia, right down through Valencia, right down to the Balearics. So there we are. Okay, well, Daz, do you want to just very quickly go back over the questions for the quiz? Are you on mute? Yes, you are. We'll give you the quiz answers. Don't the quiz? Not we'll give you the answers.
Don't give the answers.
Can't hear you, Daz.
Yeah.
Okay.
Right. Okay. Can we hear you now, Daz? Obviously not.
Right, you can. Yeah, you can hear me now.
Okay.
It's all right. I was on another page, so I had to come over.
No change.
So I've just got to go back again.
Yeah. Okay.
Right, here we
so
can you see that?
Yeah, we can. Yeah. So just very
Right,
quickly go through the questions.
Let's quickly go. We'll literally go through them. Right. Okay. Then. So, right. Number 1. Name the 4 largest moons of Jupiter and what is another collective name for these moons. So again, name the 4 largest moons of Jupiter and what is another collective name for these moons. The second question is Mars. And that's all you're getting, Mars. Now, question number 3. Can you name the 4 fundamental forces which govern all interactions in the universe? Again, can you name the 4 fundamental forces which govern all interactions in the universe? 4. What phenomenon do we experience on Earth which is influenced by Earth's axial tilt and orbit around the Sun? So again, what phenomenon do we experience on Earth which is influenced by Earth's axial tilt and orbit around the Sun? 5. A series of 4 consecutive total lunar eclipses with no partial lunar eclipses in between is known as a what? So again, a series of 4 consecutive total lunar eclipses with no partial lunar eclipses in between is known as a what? 6. Please name the 4 main classifications of types of galaxies. That doesn't sound right. Please name the 4 main classifications of types of galaxies. Number 7. Mercury, Venus, Earth, and Mars. Again, that's all you're getting. So it's Mercury, Venus, Earth, and Mars. Number 8. What is Chon? C-H-O-N. Again, what is Chon? C-H-O-N. What 4 directions of the celestial sphere are often used in navigating and understanding astronomical observations? Again, what 4 directions of the celestial sphere are often used in navigating and understanding astronomical observations? And finally, 10. What are the 4 stages of our sun's evolution? Again, what are the 4 stages of our sun's evolution? And that's it. Thank you very much.
Thank you, Daz. Thank you very much indeed. Yes, so don't forget, viewers, just write down your answers, put them in an email, mail them to giveaway@spaceoddities.space, giveaway@spaceoddities.space. We'll have a look at them. Well, Daz will have a look at them. He will grade your answers, and we will come up with a winner. And if we get a tie, we'll choose a winner at random, and we'll let you have both the answers to the questions and give you the name of the winner next Tuesday. Speaking of next Tuesday, we have a very special guest joining us on Space Oddities next Tuesday. Mel Quinn makes her return to Space Oddities on Tuesday. We spoke to Mel quite a while ago now when she was head of Spaceport Cornwall, and she's moved on to other things now. So all of them really exciting. So we're going to have a chat with her about what she's up to next week. So you've got that to look forward to. And there you are. So thank you so much for sharing our 4th anniversary program with us. We obviously want to keep bringing you more of the same for the next 4 years. And don't forget, you can donate to Space Oddities. If you want to donate directly, you can click the super chat icon below the chat window. It's the one with the $sign on that will allow you to make a donation directly. Don't forget to like, subscribe, and comment. I know I keep saying this, but any comments you leave on our videos, once the video has been published on YouTube, really helps the algorithm notice our videos and recommend them to more people. So if you could do that, that would be fantastic. So until next week, we wish you a fantastic week. Look after each other. Stay safe. Thanks for being here for our 4th anniversary program. And thank you for your donations. Much appreciated. And we'll